Welcome to All This Math. This is Professor Parker, and as you can see, I have my Mission College sweatshirt on with the logo, Uplift the Race, and this is one of the ways that we uplift the race by developing our math skills so that we can solve our problems. All right. Mission College is actually a fictional college. It's a fictional university from a movie by Spike Lee that came out in the 80s called School Days. I highly recommend that movie if you have not seen it. Also, if you've seen it back in the day, I highly recommend that you go rewatch it. It deals with a lot of issues that, confront us or a lot of issues that we need to confront as a black community in order to move forward and actually uplift the race. All right, now that I said that, let's get into the task at hand. So on this particular video, I want to talk about exponent rules. Exponent rules. Now, exponent rules are basically a set of rules that we really are just going to have to memorize. But we memorize them through repetition, through consistent use of the rules. So that way, when we look at a problem, right, we look at any type of problem that includes exponents and variables and numbers, we automatically recognize which rule to apply at which time. And also we recognize that you don't have to always use the same rule in order to get to the final answer. One of the things that confuses some people about exponent rule problems like these I have behind me is that you actually have options. So you actually have freedom to use this rule, or you could use another rule, right? And you'll still get to the same final answer. It's kind of like trying to get to your house, right? You can take the scenic route or you can take the highway. It don't matter, right? You're still going to get home, right? So I'm going to show you how we use the exponent rules to simplify these three examples. So we start with number one. Number one is a fraction. Actually, all three of these are fractions, okay? We start with number one. We have x to the negative 2 power divided by the quantity, because this is inside parentheses. So the quantity, x to the 5th times y to the negative 4th, all raised to the negative 2 power. Now, as I said, you have options, right? And there are different rules that you can use. What I would do first is I would get rid of these parentheses in the denominator first. That's what I would do first. I want to get rid of parentheses. And there's a rule for that. Most textbooks call that rule the power rule, right? We just write that up here. The power rule, because you already have this x to the 5th power and this y to the negative 4th power. But then outside of some parentheses, you got another exponent. So that some textbooks call it the power of a power rule, because that's kind of what it is. It's like x to the 5th, then raised to the negative 2 power, right? Y to the negative 4, then raised to the negative 2 power. So some textbooks call it the power rule. But when I think of it, I like to think of it as the distributive exponent rule, because really what you end up doing is you end up multiplying whatever exponent that's outside by each exponent inside. Again, I repeat, you end up multiplying each exponent outside, well, in this case, there's only one, times every exponent inside, right? So that's going to look like this. And again, I'm not doing nothing with the numerator, not yet. Not yet. I'm leaving that alone for now. So I'm just going to rewrite it. So I write x to the negative 2, and then this 5 gets multiplied by this negative 2. So that becomes x to the negative 10 power, because we got to know how to do arithmetic with positive and negative numbers, right? 5 times negative 2 is not positive 10. It's negative 10, right? Also, don't confuse the power rule with the multiplication rule. The multiplication rule says that you add the exponents. But when you use the power rule, we multiply the exponents. That's why I like to think of it as the distributive exponent rule. Because if you understand the distributive property, where if you have a number outside of a set of parentheses, and you know that you have to multiply that number by everything in the parentheses, you can kind of make a mental connection, right? Now, the same thing with the y. You got negative 4 times negative 2. That gives me y to the positive 8. All right? Now I got rid of the parentheses. So now I got to look at this and I got to say, what rule can I use now? Because I got rules. I got rules that I can use, but I got to think about what rule can I use. So I know one thing I could do. I could use the division rule with these two x's. I could simplify those x's by using the division rule. The division rule for exponents says, let me put it up here. The division rule says that when you have the same variable or the same number, you subtract their exponents. you subtract their exponents. Now, another question you probably have is, well, do I subtract bottom up or do I subtract top down? Typically, we subtract top down. Now, there are shortcuts that are involved. When you get a little more advanced in this, and you can get a little, you feel a little more comfortable, you can subtract bottom up. But we're not doing that right now. The standard is we subtract top down. So we do -2 minus -10, right? So that's going to be my next step. But then the question also should be, well, where does the x go? Does the x go in the denominator or does the x go in the numerator? Okay. When we use the division rule, we keep that variable or that term or that number in the numerator. So I'm going to write my x up here, and I'm going to have -2 minus -10 over y to the 8th, right? Now, we got to be careful about these negative signs. You got to be careful about negative signs, right? Be careful with your negative signs. Don't leave none of them out. Because remember, this is already a -2. The division rule says that we have to subtract. So that gives me this negative sign or this minus sign. And then my exponent down here is a -10. So that's -2 minus -10, right? Now I keep going. I'm almost done. So now I got -2 minus -10. That's a double negative. Whenever we have a double negative, that becomes addition. So it really becomes -2 plus 10. -2 plus 10. -2 plus 10 is +8. So this is going to be x to the 8th over y to the 8th. Now, when I get to this point right here, there's nothing else for me to do. I've simplified as much as I possibly can. I've used every rule that I could, right, in order to simplify as much as I can. So I just draw a box around this because this is my final answer. X to the 8th over y to the 8th. Now, remember what I said earlier. We do have options in terms of which rules we could use. I could have used the negative exponent rule and took the reciprocal of this x and took the reciprocal of this x, which basically means I could have flipped it. I could have threw this x up on the top and I could have threw this x on the bottom. Now, what's the purpose of that, though? That's called the negative exponent rule. Negative exponent rule. The purpose of that is so my exponents can become positive. Because I want you to remember this. You can't use an exponent unless it's positive, right? If it's negative, it's just there, right? It's just there. But you can't actually use it unless it becomes positive, all right? So the purpose of the negative exponent rule would be to make my exponents positive. Because what I could have did was this. I could have flipped this x and flipped that x, and then I would have had this x to the -10 on top. So that would have been x to the +10. And then this x to the -2 would have went down bottom. I would have had x to the +2. That's the negative exponent rule, right? Anything that has a negative exponent, you move it to the other part of the fraction. Anything that has a negative exponent, move it to the other part of the fraction, right? Oh, my fault. That y to the 8th wasn't on top. And that's another mistake people make, though, right? I'm glad I did that. That's another mistake people make. They just try to just start moving everything. You don't move everything. You only move what had a negative exponent. This had a negative exponent, so it can move. This had a negative exponent, so it can move. This y was cool. This y had a positive exponent. If it's got a positive exponent, let it chill. Leave it there. It stays in the denominator. It stays there, right? So now I can use my division rule with the x's, just like we did right here anyway. So now I got 10 minus 2, which is x to the 8th over y to the 8th. And ain't that the same thing I got right here? So you see how, like, when we use different rules, we still get to the final answer. Like I said, like, it's a lot of ways to get home, right? Some ways are longer than others. Some ways will require you to use more gas, but you still gonna get home, right? So when you have problems that involve the exponent rules, I want you to think about, like, what rules you can use and when you can use them and how to apply them in the most efficient way, right? And a lot of times there's no one correct answer. Like, if I'd have went this route, I'd have still been cool. I would have got to the final answer. The first way I did it, I was cool. I got to the final answer. Either way, you get to the final answer. It's all good. All right? So that's the first example, right? That's the first example. Now let's look down at number 2. Now let me erase this right here. Give myself some space. Because this one involves a couple other rules that we didn't use yet. We already used the power rule, the division rule, and the negative exponent rule. Now, with number 2, I'm just looking at number 2, and I'm like, okay, check this out. I see parentheses, so I can use the power rule. I know I can use the power rule. But then down here in the denominator, I see m to the third and m to the second. So I know I can use the multiplication rule. Multiplication rule. I know that's real sloppy, but multiplication rule, right? That's what that means. Now, when I use the power rule, this is what I do. Again, it's like distributive property. That's like what it is, like distributive property. So I do 2 times 4, which is not m to the 6th power. That's a common error. People know they're supposed to multiply, but they end up adding. It's m to the 8th, right? Now down here, m to the 3rd times m squared. That's multiplication. So we use the multiplication rule. In the multiplication rule, when you have the same variable, you add the exponents. You add the exponents. You don't multiply them, right? You multiply them when there are parentheses involved. But when there's just straight multiplication, you add the exponents. You write that variable one time, and you take the sum of the 2 exponents. Because really what we're saying is I got m times m times m right here, and then I got m times m right here. Altogether, that's 5 m's. That's like doing m times m times m times m times m. That's why it should make sense, right? So we got m to the 5th. So now we got m to the 8th in the numerator, and we got m to the 5th in the denominator, right? Now I'm looking, and I'm like, okay, well, what can I do now? I got an m on top, and I got an m on the bottom, right? So now I know I got another rule I can use, the division rule. Like we used in number 1. With the division rule, I subtract the exponents. I can use the division rule because I got the same variable. The same variable. So I subtract top minus bottom. Top minus bottom. 8 minus 5. Which is m to the, matter of fact, I'm going to write it out so everybody can see what I'm doing, right? So m to the 8th over m to the 5th is m to the 8 minus 5. And 8 minus 5 is 3. M to the 3rd. That's the final answer. M to the 3rd, right? So again, it's all about learning the rules and then knowing when to apply the rules, right? It's just like anything in life. You learn the rules and then you know when to apply the rules, right? It's like playing video games. You learn the rules of, what the different characters in the games can do, and then you apply them when it's most appropriate. But you got to recognize what the situation looks like to know when to apply the appropriate rule. All right? Now, number 3, I'm going to show you something called the 0 exponent rule. The 0 exponent rule says this. If you ever have an exponent of 0, everything that is raised to the 0 power turns into a positive 1. That's it. That's it. So all of this in here, we don't got to do nothing. We don't got to do all this work. We don't got to use the power rule right here. We don't got to then use the division rule for the U's and the division rule for the V's. You know why? Because all of this is going to turn into a 1 anyway. Because that's what the 0 exponent rule says. The 0 exponent rule says, that's another rule we need to memorize. 0 exponent rule, right? 0 exponent rule. Any term, variable, number, it don't matter. If the exponent is 0, it simplifies to positive 1, not negative 1, positive 1. It could be 10 trillion to the 0 power. That equals 1. It could be 1/5 to the 0 power. That equals 1. It could be this expression right here to the 0 power. That equals 1. We could do all the work inside and we're still going to get 1, right? It's a lot of different ways to do this problem. It's a lot of different ways. But the 0 exponent rule says that anything to the 0 power, that particular term, in this case, the 0 is outside of the parentheses that are around everything. So that's why everything turns into positive 1. This whole thing turns into positive 1. Now, if everything wasn't raised to the 0 power, we would still have some work to do because we'd have to break it down piece by piece. But in this case, the 0 is outside of these parentheses. So that means the whole thing turns into a positive 1. All right. So that's just a little bit about exponent rules. I hope you learned something today. Like the video if you learned something, subscribe to the page, share the video, tell some other people about it. And come on back for some more videos. Peace.